Hello everyone, so today we are going to do Leetcode daily challenge, merge two sorted lists. So basically in this question we are given with two sorted lists and we need to merge them into final list which is again a sorted one. So before proceeding, let's check for the constraint, and these constraints are like we are having each list which consists of 0 to 50, means range is 0 to 50, and as we are given with two linked lists, so at max if both of them are of 50 size, so it could go at max till 100. So that's why we could even use some solution which could go till, means at max we could, not at max, but we could use a solution of order of n also here, because it could go till 100 and then n is equal to 100, so it won't give us TLE in this case. And then the node values are from negative to positive. Also this negative and positive value doesn't matter much because we have to just sort it into ascending order. So yeah, it won't matter much for this frame. Now comes the part that how we are required to do this solution. But before proceeding with the solution, let me give you some key points. That is that both are sorted and we are required to use this particular thing, that these both are sorted, and as they are linked lists, thus we need to maintain a head pointer which could be returned at the end. This thing which we could use because whenever we are having a linked list, so there is one issue of maintaining a head pointer which could be returned at the end, because while traversing the linked list, the thing is that when we are doing next and it reaches at a point where it reaches at the last, and thus what we will be returning at that particular point when we need to return the final linked list, right? So that's why we need to maintain a head pointer also, so that at the end we could return that particular head pointer for our final answer. So we are required to consider 4 cases in this particular sorted linked list. So let's take the example 1, 2, 3 and 1, 4, 5, 6, right? So we could have one case that we are given with just one linked list. Here L1 and L2 is there. If we don't have this L1, we have just L2, or we have just L1 but we don't have this L2, right? Then at that case we would be simply returning L1 as the answer, as it is already sorted. So if we are returning a linked list as it is, so it won't matter much. Now next thing is maintain head pointer and start answer linked list. That would be the thing. That first thing which we are required to do is we need to maintain a head pointer, right? And then we will be starting our answer linked list. This is what we would be doing here. And then we are required to make an answer linked list with help of tail pointer. Basically from wherever we would be starting the head, right, we will keep it as it is, but for returning at the end we would be returning that head pointer, but with that only we would be linking our tail pointer, and that tail pointer will finally complete our linked list. This is how we would be completing our solution. And the fourth case which we need to consider is that there could be a case that these two could be like here only there could be one linked list that is smaller in size, right? And when one is smaller in size, then it will simply exit the loop, right? And we are still left with this particular node to be processed, right? So in this scenario, what we would be doing is we'll simply check for this longer left out linked list and simply add link this particular left out linked list to our answer linked list. So this is what we would be doing at the end. And this is the case which we are required to consider. Means 4 cases which are like that. First thing, we need to check that if either of them is empty, so we need to return that linked list which is being given to us. The second case would be for maintaining a head pointer so that we could return that particular at the end. And third case would be simply taking the tail pointer, which could simply give us our final answer. The second and third are simply the common things which we use in linked list, because in linked list we traverse, so we have to maintain the position in such a manner which could be returned. And a fourth point, that is because these linked lists could be of unequal sizes also. And if they are of unequal sizes, then in that scenario, what we are required is that we need to check for that particular longer left out linked list and simply need to link that particular longer linked list to our final answer. So this is a thing which we would be doing in our whole solution. So let me walk you through the code and then I'll show you up to the time complexity. Now here the thing is about, okay, can't use that, but still I'll try to use it. Yeah, I can use. Okay, so that particular first point, that if either one of them, we are not having, if either one of them, like if we don't have the first linked list, then we'll return the second one, and if we are not having the second linked list, then we return the first. So this is the thing which I was talking about in the first case. Now this is that particular thing which I was saying, that we need to maintain a head and tail pointer so that we could at the end return the head pointer and tail pointer for maintaining our answer linked list. And now the next part. This is for the part that how we are linking our head and tail with each other and how our head is being initiated, that it could be at the end returned. So here the first thing is that if L1, that is the first linked list, if its value is less than or equal to L2 value, then what we would be doing is we'll simply do head equals to tail equals to L1, and then L1 equals to L1's next. That we need to do. That is, yeah, we have consumed the L1's this particular node. So now what we would be doing, we need to proceed further to that particular linked list. Or there could be the second case, that is our L2 is smaller than, means L2's first node is smaller than L1's node. So in that case, we would be doing this part. That is, we would be having this head equals to tail equals to L2. And then we will be proceeding further with our L2. Now comes the next part. So our next part is simply like that we have till now maintained those, right? Now comes our main portion, that while L1 and L2 both exist, so till then we would be proceeding further. That is, we'll check that if L1 value is less than L2's value, then what we would be doing is we'll do tails next. That is, what's our value we were having in our tail, its next will point to our L1, and now as its next pointer has been changed towards the L1, right? So now our tail need to be updated, that a new tail would be pointing toward that L1. That is, let us say we are having this particular 1, 2, 3, and then we are having this 2, 3, and 4. Our head and tail both are at this particular only, right? And okay, let it be. Head and tail both are at this particular point only, right? So now at this particular position, what we would be doing is our tail is equals to 1, right? But we'll check that either of them which is smaller or bigger, right? So 2 and 2 both are of same position only. So our 1 will be simply pointing towards 2, right? And then our tail would be simply updated 2. This is what is being done here. And our L1 will simply proceed further, means at this. But till now our answer would be 1 and 2. And then like this only, we would be simply completing our linked list. And then at the end, if either one of them is bigger, say if this was more bigger than this, right, it goes till 5. If that was the case, then we'll check that if L2 doesn't exist, right? But here L2 exists, right? So it will go to this particular case, and at that point tail would be there, and tails next would simply become equals to L2, and as whatsoever was there, it will be now simply linked to this particular, and we don't need to further traverse into that L2 also. So that's why we will end up here only, and then at the end we'll return our head, because head would be the starting pointer of our answer, and that's why at the end we'll simply return our head. So this was all, and the next thing is about the time complexity. So the time complexity would be simply if L1 is of n size and L2 is of m size, right? So the time complexity is simply, means time complexity will be simply m plus n, and the space complexity, because it is simply pointers only and we are not using any extra space, so it is again, or it's order of 1 only. So this was here the time complexity and the space complexity for this particular solution. So this was all for this. So thank you.